This is Zach's house. Imagine Zach's surprise when he went to get a drink of water from the faucet and nothing came out. He called the water department, who advised him he had used over 300,000 gallons of water within a month's time. This is highly indicative of a main water line leak. Unfortunately for Zach, he had just poured a $10,000 RV pad next to his home, where his water meter sits. Zach called the directional drilling company to come do what they could to get him a new water line. Today I'm going to talk to you about the directional drill locating system and give you a clear understanding of what that entails. My name is Christensen. I've co-owned a plumbing company for more than a decade. Part of that plumbing company is horizontal directional drilling. We offer that as a service to our customers for utility installation. I've attended classes, workshops, and expos offered by world-renowned drill manufacturer Vermeer Corporation and the manufacturer of the locating equipment I'm going to talk to you about today, Digital Control Incorporated, and other industry leaders as well that have put on classes and any other information I can get my hands on regarding drilling. My team has installed hundreds of thousands of feet of water lines, sewer lines, communication fiber, gas lines, and power lines via directional drilling. My biggest measurement of experience has been communicating with other drill companies, trial and error, learning through successes and failures, having to look up in guides to see what you did wrong, and make phone calls and read forums and troubleshoot processes as you're on the job. Today I'm going to tell you about the locating equipment in a directional drilling system in 3 different ways. First, I'm going to tell you about the components of the locating system. Then I will tell you how to calibrate that system to ensure that it's accurate and you can even successfully complete your job. Last, I'm going to tell you about how all of those components work together to make a successful bore job. The components in a locating system include the remote display, the receiver, and the transmitter. The transmitter is also known as a sonde. It sends the frequencies from the drill housing where it sits. This is the drill housing and the drill head, what goes into the ground. The transmitter goes into that and sends frequencies to the locator, who is the person holding this box. The locator is a position, not a thing. So I am a locator, this is a receiver. As a locator, I hold the receiver as I perform my job and receive the signals from the sonde in the drill housing. This is a drill screen. It displays the reading that are sent off by the transmitter to the receiver for the drill operator to see so that he or she can communicate with the locator. And the locator can identify the information being received and explain to the drill operator what they want them to do. As I mentioned, this is the drill operator, the drill screen. The receiver is the box that the locator is managing. And the drill sonde or the transmitter is underground in the drill head. Now that you know the components of a drilling system, I'm going to talk to you about calibrating that system to ensure accurate results. To calibrate the system, you set the receiver on the ground on a flat surface that is earthy, not surrounded by power lines underneath or overhead. You measure out a distance of 10 feet between the transmitter or sonde that sits in the drill housing and the receiver, and then you calibrate the receiver by a selection on the receiver screen. If that measures at 10 feet, then you're good to go. Next, I'm going to tell you about how all of these pieces of the puzzle work together and communicate. The transmitter signal comes out of the sonde just like this. Imagine a big chocolate donut sitting on its side, and the transmitter goes through the middle of the donut. Now, the signal that is sent from the transmitter is much like the shape of that donut. It sends it out from the middle, just like that. The receiver receives the information from the transmitter at a 70-degree angle. So no matter the direction of the sonde or transmitter underground, it's always going to be the 70-degree angle. there's a point where that angle meets the surface, the ground surface. At that point, on the front side of the angle is called the front locate point. On the back side of that 70-degree angle is the rear locate point. The middle line at 35 degrees in between the angle is called the locate line. That is the middle of the receiver, always. Now, when the receiver is pointed toward the surface, the rear locate line or rear locate point will be further from the locate line than the front locate point. However, just the opposite, if it's pointing down, then the rear locate point will be closer to the center line than the front locate point. Additionally, as far as depth is measured, the deeper it is, the further those two lines are apart. The closer to the surface, the closer they are together. As the locator marks the rear locate point and the forward locate point, the locator will drag the box between those 2 points, and a line will display on the locator's screen. That line is going to show you the locate line, as I mentioned, which is the center of the transmitter. At that line, you're able to pull a depth reading on the transmitter to know where your drill is. The transmitter also reads pitch, which we were talking about the angle. It reads frequency, which tells you how close you are to the sound and if you're in the right spot. It reads temperature, and it also reads the roll of the transmitter like a clock face. So that roll of the transmitter indicates what direction your drill bit is pointed. All drill bits have a slant on the end. Flat down is up. That's a 12 o'clock position. This one is pointed to the right with a slant. That's a 3 o'clock position. So if I wanted my drill operator to go quickly to the left of where they were drilling and slowly rise, I would say, drill operator, move in a 930 position for half a rod. That would turn the drill into a quick manner, into a position that would move the drill quickly left, slowly up. On the other hand, if I wanted the drill operator to move quickly down and slowly left, I would say drill operator, move at a 530 position for half a rod. Now that you've understood the components of the system, the receiver, the remote display, the transmitter, how they're calibrated, and how they work together, you have an overall idea of how the locating system works. Bob and Zach saved surface disruption by not having this line drilled or excavated. He saved time and he saved money. The locating equipment allowed us to steer the drill into the 12-inch by 6-inch area that we cut in his basement mechanical room to pull that line in. We pulled the line out, and in 4 hours, Bob and Zach had a new water line installed. And it could have been a mess. Thank you.